So I'm going to solve a couple of inequalities like we did in this homework. I think some people are having problems with an issue, and I'll try to address it here. So if I have an absolute value with a less than, I'm going to add a term here. How is that different than having this? Having a greater than 7. So the first case are the ones we said that is a little bit easier. This was in the homework that was due on Monday last week. So these problems you can do them by solving first. Both cases will have similar steps in the sense that you first step would be to isolate the absolute value part. This should be less than 5. In this case, though, you have, of course, greater than 5. So in that sense, they're the same so far, but here's where it's different. This one, you're saying that the inside of the absolute value bars has distance at most 5 from the origin. That means that the quantity x plus 3 has to be between 5 and negative 5. And I can do it in one step. I can write one inequality. So x plus 3 should be between negative 5 and 5, and I can subtract a 3 from every point, each part of these 3. Take away 3. And it does work. You have a negative 8 less than x less than 2. So at the end, your solution is the interval negative 8 to 2. Okay? Well, on this side, in this case, or over here, we kind of already know the answer. If these are the numbers that are whose distance are less than 7 from the original problem, right? You can't see that. From the original problem, these numbers, this set has distance less than 7. The outside of this is what should be the answer for this. So know that the answer should be anything, the answer for this one should be anything before the negative 8. So this will be between negative infinity and negative 8, and or after the 2, right? From 2 to infinity. So that should be the answer. So how do we get that answer if we don't do this work? Well, the work we do is a little bit different. I mean, if you want to address how to do this, what you do is, well, you have to write now, instead of saying that x plus 3, look at this part, is less than 5, now you need it the other way around. You need 5 has to be less than x plus 3, right? Instead of looking at this part over here, where it says negative 5 is less than x plus 3, you want it on the other side. So you really have x plus 3 is less than negative 5. So how do you go from here to here, right? You get these two. If you don't see the left side, you will go, the inside of this absolute value now has to be more than the positive 5 or less than the negative 5. That's the way I think about it. So in this case, you have two cases. You do the work here, and we're going to do it on one color. So this will give you x is less than negative 8, which is correct. It gives you this part. This one tells you x is greater than 2, which gives you this part, and we got the right answers, right? Okay, so these are the two differences for these kind of different problems. Now, the little thing that happened is that the issue that happened, I think, in the homework is that you're having some problems that have a little bit different. They have something where something else is going on and getting students confused. So what if I write something of the sorts 2 minus absolute value of x minus 3 less than 3? So if you look at this example first, it looks like it's the first case where we have an absolute value less than a number, right? Less than a number. But the truth is, I have this negative here that's making a big difference on this inequality. Because I'm going to do this for the first same step as before. I'm going to isolate the absolute value. Okay. So I'm going to remove the 2 So I have negative absolute value of x minus 3 should be less than, I subtracted a 2, so now it's less than 1, correct? But here, the problem is that I'm not done isolating the absolute value bars. I still have this negative here. So I'm not done isolating the absolute value. And here's where you have to remember that if you need to multiply both sides of an inequality by a negative or divide by a negative, you have to swap the sign over here. Okay. One way to explain that, so let me write that down. So basically, this will turn out really to absolute value of x minus 3 greater than negative 1. Okay. The problem, one way to address that is that instead of multiplying both sides by negative 1, which sounds pretty strange maybe, one way you can address that if you don't want to do that is take another approach and say, why don't I add this to the other side? This is the same thing, right? If I add this quantity, it's on this side of the 0. Now subtract the 1, and you have negative 1 less than absolute value of x plus 3. So this is why, see, these two inequalities are exactly equivalent, right? Only that they're written backwards. This says the number x minus 3 is greater than negative 1. This one's saying the same thing. Negative 1 is smaller than x plus 3, the absolute value, right? So, so this is why, although it looked like it was an absolute value with a less than sign, at the end you really have to address it like the second case. Okay, now this example I chose here has another thing that is interesting, is that the solution for this inequality is all real numbers. I don't have to do any work at all because no matter what is inside this, an absolute value is always positive. So for sure it will be greater than negative 1. Okay? So I hope you see that this is true for all real numbers. So I don't have to do anything at all. This means the solution would be, if you want to write it as an interval, would be from negative infinity to infinity, or you can write all real numbers. But that's another issue, right? The thing I wanted to address was that although this originally looked like a less than, when you have a negative on this side here, to address that you have to change the sign or flip to your side so it turns out to be with this on the other side. Okay, hope that clarifies this.